4. So weight is how much weight is nothing but we have just calculated in our question A. Weight is nothing but 3.4 into 10 raised to 4 Newton. Okay, so this is the value of the weight. And what is the perpendicular distance? We had just seen it should be equal to 1.8 minus 1.3. Should be equal to minus, right? It should be equal to 1.8 minus 1.3. Okay, so here we can write down it is 3.4 into 10 raised to 4, 10 raised to 4, and 1.8 minus 1.3 is nothing but 0.50. Okay, multiplied by 0.50. Okay, so here calculation of this 3.4 into 10 raised to 4 into 0.5 is giving us the value of 1.7 into 10 raised to 4. So this is our value. Okay, this is our final value, and the unit of this moment is nothing but Newton into meter. Newton into meter. So here also we can write down the final value, that is 1.7 into 10 raised to 4, and the unit as well, that is nothing but Newton meter. So here writing down the answer here is very important, otherwise you may lose 1 mark, and writing down the answer along with the unit is very important. Now you can see here second question. A concrete block is positioned on the other side of the support post with its center of mass at a horizontal distance of 70 cm from the center of the support post. So here you can see this concrete block is kept on the left hand side, and the center of mass of this concrete block, and that is nothing but, you can see here it could be the center of mass of this concrete block, and the center of mass is at the distance of 70 cm from the center of this support post. Okay, so state what is meant by the center of mass. What is the meaning of the center of mass? It is nothing but the point where the all the mass of the body can be considered to be concentrated. Okay, so you can write down here, it is the point where whole mass of the body is supposed to be concentrated. Okay, so this is the one point where we can say whole mass of the body is concentrated, and if you apply the force to that particular point, entire body will move in the straight line. So that is nothing but the center of mass. All symmetric bodies, for all the symmetric bodies, the center of mass is nothing but its geometric center only. Okay, so here you can see question number sub question number 2. The weight of the concrete block produces the moment here about a point P that exactly cancels the moment caused by the weight W. Okay. Calculate the weight of the concrete block. Okay. So here you can see the moment produced by the weight about a point P is exactly the same as the moment produced by this concrete block about the point P. Okay, so that is nothing but called as the principle of moment. So this is the principle of moment is F1 d1 is equal to F2 d2. Here this is a pivot, and at this point this is a rod. You can say the rod distance of this extreme point of the rod from the pivot is d1, and at this point force F1 is acting. On the another extreme, force F2 is acting here, and distance of that extreme point from the pivot is d2. So here F1 into d1 should be equal to d2 into F2, so that this rod will be in the balance situation, and that we can say these two moments F1 d1 and F2 d2 are cancelling each other. So this is called as the equilibrium position. So in this case also the moment produced by the weight about point P is equal to the moment produced by this concrete block about point P, and that's why they can cancel each other, and that's why only this support post is not falling either on the right hand side and left hand side. It is exactly standing vertically constantly, because the moments are equal and opposite. So we can apply here this principle of moment, and we know that this weight, we know that the weight, the distance of this weight from the point P that we have already calculated. Now, and the distance of this concrete block from the point P is also given. We can calculate this distance. This distance we need to know to calculate the moment. This distance is how much? This is nothing but this 1.3 plus this 70 centimeter. Okay, that is nothing but 0.7 meter. And we need to find out what is the mass of this concrete block. So we will apply here the principle of moment. I will copy this equation directly over here. So this is nothing but F1 d1 is equal to F2 d2, where F1 is nothing but the weight of the concrete block, and we need to find out the weight only directly, and d1 is the distance of that concrete block from the point P, and here you can see this is nothing but 70 centimeter plus 1.3 meter. 70 centimeter is 0.7 meter and this is 1.3 meter, so this is the total distance. So we can write down over here. So I will write down weight for F1. F1 is nothing but the weight of the concrete block, and distance is nothing but 0.7 plus 1.3 is equal to nothing but here F2d2 is what? It is nothing but the moment of that weight signboard about point P that we have already calculated, and that is nothing but 1.7 into 10 raised to 4. So here we can calculate this remaining part. This is weight W multiplied by this 0.7 into 1.3, that is nothing but 2, that is equal to 1.7 into 10 raised to 4. 1.7 into 10 raised to 4. So here we can calculate what is the weight W. I will write down here this way. So weight W is nothing but here is equal to 1.7 into 10 raised to 4 divided by this 2. When this 2 will go to the right hand side, it will go into the denominator. So we will get the value of the W, that is the weight of the concrete block, is nothing but equal to it is coming out to be 8.5 into 10 raised to 3. 8.5 into 10 raised to 3. The unit is nothing but Newton. The unit of weight is Newton because that is nothing but the force itself. So this is the calculation part of the weight of the concrete block, and that is coming from this principle of moment, that is nothing but F1 d1 is equal to F2 d2. So we can write down this weight again over here, that is nothing but 8.5 into 10 raised to 3 Newton. Okay, so this is our sub question number 2. Now part C of the question, the concrete block is removed, the sign and the support post rotate about the point P in the clockwise direction. State and explain what happens to the moment about point P due to the weight of the sign as it rotates. So let's see what happens to the moment about point P due to the weight of the sign. So here you can see in the figure, if you remove this concrete block, what will happen? This entire signboard and this along with this support post this will fall in the right hand direction, or we can say in the clockwise direction. So we need